Okay, so to show events are independent, we're going to use our conditional probability formula. So this formula, okay? So the probability of A given B is the probability of A intersection B over the probability of B. Now, that probability of B comes up and it gets multiplied. The probability of A given B. Now, if two things are independent, okay, they don't affect each other at all. The outcome of one isn't affected by the outcome of another, okay? So if they're independent, the probability of A given B, think of an example. The probability of getting a red card given that I got a 6 on a dice. Do they affect each other? No, they're completely independent. So what is the probability of getting a red card given that I rolled a 6? What's the probability of getting a red card? A half. Does the given I rolled a 6 affect that? Does it change the half at all? So for independent events, the probability of A given B is actually just the probability of A. It doesn't matter the given B bit because they're independent. They don't affect each other. The probability doesn't change. So what we're actually going to use and we're going to learn off is for independence, the probability of A intersection B is the probability of A multiplied by the probability of B. That's what we're going to learn off, okay? This bit is just explaining to you why. This is the important thing. That's what we're going to use. So for independent events, probability of A intersection B is probability of A by the probability of B.
But you know the way you're saying that they're independent, so they're not to do with each other?
Yeah.
Why would you multiply them by each other then to get what the middle bit is?
So I'm going to show you now what that means. Okay, it's showing they're independent. Okay. Okay, so in a group of 60 students, 20 study history, so your 20s out there, 24 study French, 8 study both, and 24 study neither. Okay, so just fill in all your little pieces. Okay, so 20 out there, 24 out there, 8 in the middle, and 24 on the outside. So history only would be this bit here. 12, lovely. 20 take the 8. And French only would be your 16. Okay? So there's it illustrated on a Venn diagram. Now investigate if the events a student studies history and a student studies French are independent. If they're independent, the probability that a student studies history multiplied by the probability that a student studies French will be equal to the probability of history intersection French. Okay? Now, history intersection French is the same as saying history and French, isn't it? What does and mean? Multiply. So that's where this is coming from. If they're independent, this side should be equal to this side. Okay? If they're not independent, it won't work. So the probability of history is 20 out of 60. And the probability of French is 24 out of 60. And the probability of the intersection is 8 out of 60. So now let's just see, does this end up being 8 out of 60? So when I multiply them, I get 2 out of 15. And when I throw 8 out of 60 into my calculator, I get 2 out of 15. Okay? So, yes, the left side is equal to the right side, so the two events are independent. Okay, we'll do another one. Can I get rid of the board? Okay. Okay, two events A and B are such that the probability of A is 0.5, the probability of B is 0.4, and the probability of A given B is 0.3. Find the intersection. So you need to think about what you've been given here in this question. We have conditional probability. So that means use your conditional probability formula that you've learnt off. So that's my conditional formula. I'm looking for the intersection. So that probability of B comes up and gets multiplied. And now I have these answers up here. So A given B is 0.3, and the probability of B is 0.4. So I know the intersection is 0.12. Investigate whether or not the events A and B are independent. I know they're independent when I multiply the probability of A by the probability of B, and I get the intersection. So if they were independent, when I multiplied those two together, I get the same as the intersection, okay? So probability of A is 0.5, probability of B is 0.4, and A intersection B is 0.12. Okay? These two is 0.2 is not equal to 0.12. So they're not independent.